Välkommen till dagens lunchwebbinarium som är Stimulating on-demand data-driven modeling som Malik Shairyar kommer genomföra. Och han kommer från K2 och Malmö universitet. Och han kommer föredra det här på engelska så att vi switchar strax över till språk. Och jag heter Jonas Johansson och är från Svensk Kollektivtrafik och kommer vara dagens moderator. Hi Malik, welcome. You will perform this webinar and we will open with that you start the presentation, and afterwards we will also have a time for discussion and dialogue and questions. And I also would like to say to all the participants, you can ask by pull the hand up or put your hand up, or you can write questions in the chat. And we'll take them after the webinars or Malik's topics first. And after that I will present some information in Swedish about Svensk Kollektivtrafik and about next webinar and something else. So please Malik, you can start your presentation and share, and I'll leave it up to you. Welcome again.
Thank you very much, Jonas. Hope everyone can listen me and the presentation is visible to everyone.
I can see.
That's great. So, hello everyone, and thank you very much for being here. My name is Shairyar Malik, and I am a doctoral candidate at Malmö University. The department is Data Vetenskap och Media Technique. And part of my research work is done in K2, that is Svensk Kollektivtrafik Kunskapscentrum för kollektivmobilitet. So today I'll present our research work, what we are doing on simulations and simulating these on-demand mobility with synthetic demand. And it's a data-driven approach. So this research is conducted in collaboration with Jan Persson and Åsa Gevinier. They're also part of both organizations, Malmö and K2. So in the next 20 minutes, I'll explain why the synthetic demand matters for transport simulations and what we can get out of transport simulations, and what are the behavioral challenges that exist in designing these synthetic demand models, and how our modular framework addresses them. So let's dig in. So just to set the context, let's introduce the DRT concept, the demand responsive transport. It's a type of transport that sits in between the conventional bus services and the taxis. So like bus, it offers a shared ride with low cost, but like a taxi, it operates on demand, without any fixed timetable or fixed routes. It changes its routes or timetable based on the received requests. So let's start with what data we usually have, what kind of data. That is the real trip logs from past DRT operations. These contain valuable information about request, about pickup times, the origin destination pairs. But the problem is that they are bound to past operating conditions, the same fleet size, the same booking rules, and tied to fixed service hours that happened before. So what if we try to test new ideas, like scaling demand, like extending the hours of the service, or these things, the real data can't adopt them. So that's why we have limited flexibility. And to explore new scenarios, especially for policymakers or for planners. We need something more flexible. That's where the synthetic demand comes in. So how the synthetic demand fills this gap, it lets us experiment the what if conditions. For example, what happens if we double the demand? Or what happens if we shift the operating time of the service? Maybe kind of vehicles, size of fleet, type of fleet. But those experiments to mean anything, the generated synthetic demand that must look like and behave like the real demand. And this is what we call the behavioral realism. And that's exactly where the main challenge lies. So once we have this realistic synthetic demand, we can plug it into DRT simulations to test new service designs. But as I say, different fleet size, different schedules, or different rules. So the core challenge is to generate this synthetic demand that preserves the real behavior of people's traveling habits, their timings, destinations, without being considered or constrained by the history of how the original system operated. So next, I'll show you what types of behavioral challenges often exist in these synthetic models. So the first challenge is about temporal regularity. Time-wise, in real life, people often travel at similar times each day. For example, commuting, that I have shown here as an example, is commuting around 10 and returning back home at 15. But when the synthetic demand is generated by randomly sampling the trips, that regularity might disappear. And the results are distorted demand peaks. Either we can underestimate the waiting times when the trips are spread evenly, or maybe if we do some random clustering, so we might end up with overestimation. So instead of realistic morning and afternoon peaks, the synthetic data might produce flat or noisy patterns that no longer reflects the real behavior. The second challenge that we have identified is a trip chaining or intraday continuity. It's a concept like in real life, people often make linked trips in a single day. For example, they going from home to work in the morning and returning back home in the afternoon, maybe ABA. Or if we treat these trips independent journeys, that link is broken. And the model might generate two unrelated trips, maybe A to B and A to C later, missing the realistic return trip that really happened or in the real data. So without observing this chaining, the synthetic demand that we are generating can either overestimate the total trips or misplace the destination. It might produce behavior that doesn't exist in real operation. So the third challenge is about what happens across the days, like not within a single day, but how well we remember where people usually travel. This is the origin destination repetition or interday memory. So many users travel between same places on multiple days, typically home and work. But when synthetic trips are generated, like if you generate them independently for each day, not looking at the overall pattern, so the model might forget that pattern. For instance, I have mentioned in the table that a user with a half or 0.5 probability of traveling each day it means that it should go from A to B every other day. So this is what we can see in the real data, but in our synthetic model, that same probability can produce overlapping or maybe missing trips. So even the destinations might become random, like A to C or A to D. So the average travel frequency looks right statistically. We are following it statistically very fine. We are generating with 0.5 probability, but the spatial consistency that is lost. And it leads to distorted routing and unrealistic sharing opportunities. So these three missing behaviors that we have discussed up till now, the timing, the OD memory, and the chaining, these are what we address in our modular framework to generate the synthetic demand and then to plug it to simulations to see what happens when we change the parameters. So next I'll show you this in detail. So to address these behavioral gaps, we developed a modular framework for generating the synthetic demand, the synthetic DRT demand. So each model, we have designed 4 different models, V1 through V4, and each model version adds one behavioral realism layer on top of the previous one. And these layers, what we have discussed before. So all models are built on 518 days of real data that we have received from Westtrafik, bus on demand pilot that is running in that ran in Ulricehamn and still running in China and Huene. So it includes the pickup times, the OD pairs, the coordinates, the user IDs, and group sizes from that real data. That real data was the basis for the designing of our synthetic data. So let's have a look at version 1. This was our simplest baseline. What we were trying to do, it samples the trip independently using the observed trip frequencies, what happened really frequency-wise in the real data. Pickup times and OD pairs were used for this, but there was no link in between the trips, whether the person or they were doing link trips, multi-day trips, nothing. It's just following the frequency of the trips. This version represents how mostly the simulation studies currently model demand. It's random, but statistically it's correct. But yet it's not behaviorally that correct and not really near to the behaviorally near to the real data. But this is the simplest one, and we need very less data for this. Just the pickup times and OD pairs. No user signature, no daily signature or multiple day signature. Then we increased another layer on top of it. That is the trip chaining. We added the user level data into it from the real data. Then we have seen that what were the chains that users were following within the same day. So we define this trip chain length probabilistically that the probabilities that we have seen in the real data. And OD to OD transition was the same as to reproduce the intraday continuity. So this model addressed the third challenge that we have discussed before, the missing trips and unlinked journeys. Then we move a step further with version 3, and this adds the temporal regularity. Again, now we are the usage of data is increasing from level 1, level 2, and level 3. Now we are using more data based on the user activity, because now we are checking the weekly activity of a specific user. They are anonymized, but their user ID is leading us to their weekly activity calendar. So each synthetic user has a preferred pickup hour sampled from Gaussian distribution from the real data. So users traveled roughly at the same time as on their active days as it was in the real data. This model recreates the daily time rhythm that random sampling destroys. Again, this was the final hybrid version in which we have included all of the layers that we have introduced before, the frequency, the trip chaining, and the user level preferred hours or preferred days. So this version adds the OD memory or inter-day repetition. Each synthetic user has a habitual origin-destination pair. It's reused with the same probabilities that we have seen in the real data, and it reflects the share of the user in real data that who repeat the same OD. Now, this completes the behavioral realism triangle that we have seen before, the chaining, the timing, and the OD memory. This is what we have introduced. And these four models, V1 to V4, gives us the structured way to measure how behavioral component influence the realism of simulations system performance. Now I will show you how these synthetic demands are used inside our simulation environment. Let's have a look. What we have used is open source MathSim to simulate the empirical data and synthetic models data to get the key performance indicators for their comparison. You can see how the system dynamically allocates the DRT vehicles to trip request. Each triangle is representing a vehicle fulfilling passenger request, and each line is a vehicle route based on a real map and speed limits. We have simulated the same for the real data and then the synthetic models that we have defined for all 518 days. What's important here is not the animation itself, but the control that we are getting in the end. It's the demand behind it that comes from our synthetic framework. It's realistic, it's user-based, and it's not tied to the historical schedules. Now we can play with it, but again, it's realistic. So when we play with the parameters, the KPIs that we are getting out, that would be more realistic to the one that one can say it's just a random generated demand. So now let's have a look at what this realism means in numbers. So how these four models compare across the key performance indicators. So this table summarizes the key performance indicators for our simulation runs, comparing the four synthetic demand models V1 through V4 against the simulated empirical baseline. That was the real data. We have used those requests and directly simulated them. That is V0. So it is the simulated empirical model with original parameters. So we include the passenger level metrics like waiting time, in-vehicle time, as well as the system metrics like vehicle kilometers, total or revenue or empty kilometers, detour distances, and shared ratio. Don't worry about the details here. On the next slide, I'll highlight the main patterns, the results that we have found for our models. So here is what we see when we compare all four synthetic demand models against the empirical benchmark. Now, it's important to note that there is no single synthetic model that outperformed all others. But it was each version performs best on certain aspects that we have summarized as KPIs. First, looking at the average time, average waiting time. That's the passenger experience side. V2 best produces the real world real waiting times, and meaning that it adding up the chaining, it captures the realistic travel rhythms. because you remember in V2 we have introduced the chaining. So that might be the reason why we are getting the average waiting times very near to the simulated empirical data. Next, if we move down toward the empty kilometers, so this represents operational efficiency. So V3 performed. You remember in V3 we discussed that we have introduced weekly preferred hours of a specific user. We were following the signature of a user in V3. So simulating the V3, the temporal regularity introduction, it helped to move very close to the empirical data empty vehicle kilometers. And finally, when we look across all the indicators indicating shared distance and total VKTs, so V4 gives the most balanced performance between passengers and the operators, because it includes all the behavioral components, what we have discussed, the triangle, you remember, the chaining, the timing, the OD memory. So in short, we add the behavioral realism, both passenger and system level metrics, and it progressively aligns with the real operations. So let's go to the summary, what it means for future modeling. To summarize, we first propose the modular framework that incrementally adds the behavioral realism to synthetic demand generation. The framework consists of 4 models, V1 through V4. Each incorporates one key behavioral component as an added layer, trip chaining or temporal regularity or OD memory. So using this real data trip, DRT trip data, from Westrafik, we have showed that this framework can generate synthetic demand that looks and behaves like real users. So now what does this mean in practice? Like, how does it affect the simulation outcomes? This is what we have discussed. That so every behavioral feature we added, it makes the synthetic demand more realistic. And that's what we got as the output of simulations too, and which in turn makes the simulation results more trustworthy for planning. So finally, what we can build on this as the next step, we aim to calibrate and extend this framework to 2 main dimensions. First is the multimodal setup, so that combining the DRT with the fixed route buses or other flexible modes. And second is to test its transferability across different geographical context and data availability levels. Because you know what I have mentioned when I was mentioning different models, there is a different data requirement for every model. Very less data requirement for the first model, the crude one, then the user behavior, a single day. Then we need a weekly signature for V3, and then we need everything for V4. So it depends what kind of data we are available with. That model can be used and can be adopted to that specific geographic context by changing some parameters that are related to the real demand of that specific geographic context, because it's the matter of changing the probabilities and the parameters that we are going to transfer to the new geographic context. So the long-term goal is to make synthetic demand generation a reliable tool for evaluating the new public transport design before the real-world trials. So that was the whole short summary, that where we are and where we are headed to. So within this simulation setup, we can test different service designs before anything is implemented in reality. On the left-hand side, you can see the type of the inputs that we can explore. For example, different fleet size and vehicle types, or fleet types, or changing the service hours, booking rules, adjusting maybe maximum number of ride times, or testing different geographical setups, such as zones or door-to-door. So we can also run what-if experiments, like what happens if we double the demand or increase the demand or increase or decrease the operating hours. On the right-hand side is where it becomes useful for planners. Like parameters can be adjusted through a very simple interface. The simulation runs and the KPI updates as a result. So this gives the picture of expected waiting times, or in vehicle time, empty kilometers, or whatever key performance indicators we are using to assess our system in future. So these all, and this is what we are planning to do before any real world changes are made. So this is how we can use the simulation framework and the synthetic demand to see what and how we can play with the simulations to see the upcoming future pilots or future transport or DRT projects. So that was the whole discussion for today. Thank you very much for listening, and I hope you really enjoyed it and hope you understood what I talked maybe. Thank you very much for this.
Thank you, Malik. We open up now for questions. Put your hand up or write some in the chat. So we will take them in order. But I can start with one question, so you can, the others can maybe pinpoint some few new ones. Yeah. What are the main challenges you foresee when extending this model framework to a multimodal setup that includes both DRT and fixed route lines?
Challenges, because in ModSim, it is possible to run and simulate multimodal setups.
Yeah.
And we have in hand that kind of data from Västtrafik. Now it is our next project, and what we are doing here to run this in parallel with that kind of data. But the problem with that, what we have found as a challenge is because in simulations you can simulate the real environment, but there are limitations. There are limitations for whatever is happening in reality, or to what extent you can copy the environmental changes, the system changes that is really happening in the system. That could be a challenge for when we are doing the multimodal setup. Another is that the level of the data, because if we are just this is what I have tried to explain, that with the increasing level of data, it increases the behavioral realism, but also the complexity is increasing, and maybe the flexibility of playing that would also be decreased when we are behaviorally at very high level. So this is a trade-off in between. So Jonas, this was a question that posed to me before, and they said that if we want to maybe implement in our own area, what would you need for that? So these kind of challenges, that what data level do we need, and what level of realism that we can achieve with this simulation. These kind of challenges that exist in while we do the multimodal simulations too.
Yes, thank you. And we had 2 questions now in the chat here. So I'll start with the first one. Could the simulation model also cater for traffic already run on demand, in example, taxi traffic?
I have to see the question. I don't understand maybe the question. Maybe let me open the chat.
Yeah.
And could the simulation model also cater for traffic already on demand, that is taxi traffic? Yes, we can introduce that as a traffic in the parameters, but that really depends that what level we are going to introduce. maybe, because when we are simulating, we are using the roads that is from the real map, the speed limits, the signals, and the buildings. Then in ModSim, there is a possibility that we can introduce these parameters, that what traffic level would be, that is already there. So this might change the results. So yes, it is possible.
Okay, thank you, Malik. The next question you see also in the chat are fixed route services offer the potential to operate more capacity and more cost effectively than DRT. Yet DRT/microtransit offers a great complement. How do you design this hybrid service offer, and does it change by time of day?
Yes, because the real data that we have received was from remote municipalities, Ulricehamn and Skene and Skene. So when we are comparing it like capacity-wise, like cost-wise, if the bus that is full, so the DRT can't directly compete with it, because that would always be efficient cost-wise to the planners, to the policymakers. But what if we are talking about an area where there are the people, they are living far away, and the demand is not at that part, that we can't use the full-size buses at fixed timetables, because that would increase the empty kilometers. So if we plan for those areas with the demand responsive transport, that would become the best thing. And also what you have mentioned with this hybrid service offer, we have some specific times of the day. That would also be a great idea, because yes, when we are planning for the service, we are limiting the service hours. So in the multimodal setup, we can limit the hybrid setup, at which time these model will be active, so that they both can work efficiently. But we have to cater that in mind, that if the public transport is already efficiently working, that timing can also be maybe excluded from our DRT working times maybe. So that would also be beneficial. And the next question, Jonas, is how would this simulation react to larger DRT datasets with regional areas and 600 vehicles, like Westtrafik service 2.8 million journeys per year. Simulation, basically, if you have 500 to 1,000 requests per day, maybe. Yes, that simulation depends on that what kind of setups you are using. Either you are using replanning or not, because for replanning, we have to do it multiple times. So if you are not doing any replanning, so that kind of number of requests that can be catered like efficiently within time. But for this Westtrafik pilot, we had 2 to 4 vehicles running in a very small area, and maximum number of requests were 30 to 70, or maybe the peak was 120 or 130 maybe. So looking at the number of the requests, that simulation worked like without running in multiple hits. For one day, it ran in minutes. So yes, but increasing its level and then replanning, it will also increase the computational time. That's a trade-off, yeah. But the next question is, did you consider other simulation platforms, for example, Sumo, before deciding to use ModSim? What was the basis for selecting ModSim as a simulation platform? Yes, there was a option, and there are other multiple options. Other open source options are available too. My research team, they before I joined here as a PhD candidate, they tried some open source platforms for this. But then there were challenges in them. So when I joined, we first did the literature review, and we have seen that how the researchers of today, what kind of the models and what kind of modeling platforms they are using, which programming languages they are using, and what were the optimization methods. So based on that literature review, we have concluded that MartSim was the most sturdy and easily accessible. And then it was kind of a lot of modules. They are already built and they are shared freely within the community, the research community. And I'm thankful to TU Berlin because they have provided a lot of stuff, learning stuff, and the ready-made modules that we can use and plug in to run these simulations. So it was easy to use. So that's why we switched and we have used MartSim for this. So it was kind of based on that literature review that we have done. So there is another question. What's your comment or evaluation of the commercial available tools such as VR, transportations, incorporation? The simulation that I have showed you, I am using a student version for it, the VR transportation, because MartSim, it runs the simulation then for the simulation to be visible to the end user, to see something running out and to see the outputs. And that's for that, I'm using VR for that. But yes, the commercial options are available and they can be used. But at the student and research level, we have requested VIA to give their license, student license to me, and we are using to display our simulation on that license. But yes, they are available, and people often use another, I don't remember that, but MartSim, they use MartSim directly to show the KPIs, the results directly, because it's the module are ready-made, and now TU Berlin have helped a lot to give this free to use tool to show our results to the end user, so that it can, other than the coding, he can see that if I change this, what is happening. So in the form of the graphs and this, but yes, there are available options, but what we have used is MartSim and VIA for this. So
yes. Thank you very much, Malik. I think we need to close the question time now. It will be really interesting to make following up about this about simulation in open source based platforms also.
Yeah.
So I will get in touch with you later in that matter.
Thank you very much, Jonas.
Great thanks to performing this webinar. Now I will give some information from Svensk Kollektivtrafik, and I will switch to Swedish. Yes. Ja, och webbinariet kommer ni att hitta på vår hemsida och på YouTube, och då kan ni enligt den här länken eller söka på Svensk Kollektivtrafik då. Eller skanna QR-koden så kommer ni direkt dit. Vill ni ha webbinar eller vill ni ha presentationen idag, så kan ni höra av er till mig, så mejlar den till er. Kommande webbinarium, nästa i år, är den 11 december, och då kommer Jan Persson och Åsa Gevinger, som Malik nämnde förut idag, som är med i samma forskningsdelar. Men de kommer presentera mer slutsatser utifrån hur man ska se hur anropsstyrd trafik eller efterfrågestyrd DRT-tjänster, hur de bör utformas och vilka effekter de får. Så det är också en intressant föreläsning på det webbinariumet. Nästa webbinarium som vi har vi bara precis introducerat, och det är ett webbinarium från ett företag som heter Simdel. Vi har inte rubriksatt det riktigt än, men de håller också på med on-demand-tjänster och har sitt hemvistelse i Luxemburg. Och det är tänkt att hållas den 22 januari 12:15. Ni får jättegärna föreslå fler förslag på ämnen och föreläsare, så ska jag se om inte jag kan lyckas boka in fler webbinarium med intressanta ämnen och där då. Ni hittar våra webbinarium och sånt i våra kalender där ni antingen kan anmäla er till eller ansluta direkt när de startar. Och sen så vill vi också slå ett slag för den kurs som finns för serviceresor som kommer gå av stapeln vecka 5 nästa år. Och anmälan är fortfarande öppen månaden ut. Och det är en interatkurs kan man säga på en vecka nere i Lund. Och då utbildas man i allt ifrån ax till limpa som rör serviceresor, och den lämpar sig både till dig som jobbar inom region och kommun eller systemutvecklare, konsult eller politiker och jobbar med serviceresor eller kommer i kontakt med den typen av transporter. Så ni kan klicka vidare genom vår kalender eller skanna QR-koden eller sök på K2s hemsida också. Går utmärkt. Och med det så vill jag tacka för idag, och så tänker jag att kollektivtrafiken är att resa tillsammans. Ha det gott!